But yeah, there's so many forks in a very short amount of time that introduced a lot of new features and eventually made Digibyte the largest blockchain by block height. Take that for what you will. What is up, Hash Nation? Today isn't Tuesday, but it is still Token Talk Tuesday on a Thursday this time. So today we're talking about Digibyte, one of the sleeping giants of the 2017 crypto bull run. There's a lot of exciting things about Digibyte, and I want to tell you everything you need to know about it right now. So without further ado, let's hash it out. And guys, if we're just now meeting, my name is Forrest. I'm a blockchain developer in industry, and I started this channel right here to help you build your knowledge, boost your cryptocurrency gains, and to help you join the movement towards our distributed, decentralized future. And if all that sounds good to you, you want to join that movement, just go ahead and smash that subscribe button down below and hit the little bell notification button so we can hang out every time I post new content. Super appreciated, guys. Let's get into the video. So what is Digibyte? In early 2014, Jared Tate, the creator of Digibyte, released the project to the world. And Jared Tate created Digibyte as a solution for global payments and overall transaction processing at a greater scale and at higher speeds than other blockchain networks were capable of at the time. Digibyte itself is heavily influenced by the crown jewel of all cryptocurrencies, the OG Bitcoin. And I know a lot of people have their own opinions about whether Digibyte is good or bad because of how much it drew from Bitcoin and then how much it deviated from the original vision. We're not going to talk about that. We're going to talk about what Digibyte did and why. Digibyte was built to be a faster and more scalable blockchain network in comparison to Bitcoin. Much like Litecoin was, they were trying to create a blockchain network, a cryptocurrency network that can be used widely for commerce and industry at scale. And in doing this, Digibyte stuck to a lot of the core principles of Bitcoin early on, and the core feature being that it is an unspent transaction output model, or a UTXO based blockchain. Now, if you know what a UTXO is, go ahead and skip ahead to the video. I'll leave a timestamp in the description below. But for those of you who may not know what an unspent transaction output system is, or a UTXO system is, we are going to talk about that right now so we can all be on the same page. At a very high level, an unspent transaction output itself is just the output from a transaction that a user owns and that they're able to spend later in another transaction. Rather than having an account-based solution like banks, where there are debits and credits and you have a running balance at statement time every single month or on another cadence, in a UTXO model like Bitcoin, for example, your total wealth or your total balance is a sum of all of the unspent transaction outputs that you have in your wallet. I like to think of this as giving change in the cryptocurrency world. There are some similarities and some differences, but let's take an example for that. So let's just say you have 75 US dollars. To have 75 US dollars in your wallet right now, you would have to have a combination of different bills in your wallet because there is no $75 bill. Now, that being said, you can think of each of those individual bills, those individual denominations, as unspent outputs. Each of those bills is value that you have to spend from other transactions potentially that are your right and in your wallet that add up to your total balance of $75. So let's take this example a step further. Let's say you want to go buy a $28 lunch in New York City. I'm sure those of you who live in New York City know that a $28 lunch isn't really out of the question there. It's pretty crazy. But back to the point, if you want to spend that $28, you're going to have to give the person taking the cash one or more of those unspent outputs to cover that transaction. So let's just say to make up that $75, you have three $20 bills, one $10 bill, and one $5 bill. So all in all, you have 5 unspent outputs. So to cover that $28 lunch, you'd have to take 2 of those unspent outputs. Let's just say the $20 bill and the $10 bill, give that to the cashier and they would give you back $2. When they give you that change, the change that you receive back is, you guessed it, an unspent output. And that $2 goes back into your wallet to form your total leftover balance of your unspent outputs. Now, this is where the analogy breaks down a little bit, because when the unspent outputs come back in the form of change for US dollars, the cashier is limited to the denominations of bills that there are in US dollars, whether that be change or dollar bills. Whereas in Bitcoin and other UTXO models, there aren't any bill denominations or any other way that money is split up or value is split up, so that does not really apply. So let's take a crypto related example. So if I wanted to send you 3 DGB tokens or Digibyte tokens, and I had 2 unspent outputs in my wallet, one for 2 Digibyte tokens and one for 1.5 Digibyte tokens, I would have to create a transaction and send both of those unspent outputs to you to give you that 3. But I have to tell the blockchain where that change is supposed to go. So when I create that transaction, I say I want to give 3 Digibyte tokens to you, the recipient, and I want to address the remaining 0.5 Digibyte tokens back to me, back to my address. So essentially I'm giving myself change. I know how much I want to get back, and that output from the transaction is my unspent output. And that forms one of the core principles of Bitcoin and blockchain and all these UTXO model structures overall. The total input to a transaction must equal the total outputs. For example, my input to a transaction would be 3.5 Digibyte tokens, and the outputs have to equal 3.5, whether that goes to all to you or whether that goes some to me and some to you. And what happens is that's one of the preliminary checks for whether or not a transaction is valid. If there is a transaction with an input that is lower than the total output, that would mean that Digibyte coins or Bitcoins, etc., were created out of thin air. Because as you know, the only way that these tokens are created or these coins are created is through mining. And so if you had a transaction where an input of 5 Digibyte tokens were somehow equal to 5 Digibyte tokens to you and then 5 back to me, that means 5 Digibyte tokens were created out of thin air. And that is also called double spend. It means that I can give you value, but I can also take it right back. And I can spend those same 5 Digibyte tokens more than once. That is a no-no. That's something you don't want to happen. And that's one of the core functionalities of a UTXO model. Inputs must equal the outputs. And so if you think about that also in relation to your total balance or the amount of coins that you have in your wallet at any given time, you can see how computationally simple it is to figure that out. All it is the sum of your total unspent outputs. And if you wanted to validate truly over time how you got to that exact value in your wallet, a miner or a node on the network could always go back and track at your address all the transactions that you've made, the inputs, the outputs, where the unspent outputs came from to validate that you do and you are entitled to those tokens or those coins. And the UTXO model really thrives in a blockchain or a decentralized ecosystem because it can check for double spend in a very computationally simple manner. It can keep balance in a very computationally simple manner. Although the addition of proof of work is relatively inefficient, obviously reaching consensus is difficult, and that's one of the reasons why these networks have been struggling to scale overall. And I will say there are account-based blockchain solutions that operate more like banks do in terms of how they keep balance, and one of those is Ethereum. Ethereum is account-based. But obviously we know scalability is a challenge across the board, but Digibyte has really put a lot of focus into how they can scale a UTXO model, and I'm going to talk to you about all of that stuff coming up in just a second. Now there are trade-offs. UTXOs have their pros and their cons, so do account-based systems. But overall, I really like the UTXO model because of its simplicity and because of the way that it makes perfect sense. Inputs must equal the outputs at all times to verify that no coins have been created out of thin air, none have been destroyed, and it's easy to keep balance for everyone's wallet in real time. So let's dive into Digibyte and some of the more specific things related to that project. Now let's start with token economics because we just talked about tokens and coins a whole lot. Digibyte has a total supply of 21 billion coins, which obviously says, wow, that's a lot of coins. That's a lot of supply. But this was done purposefully. Jared Tate, the creator of Digibyte, thought that a larger supply would inevitably keep the price relatively low and make it easier for this to be used widely for commerce, because that meant lower value per coin, which makes a lot more sense to most people when using it for commerce because it's a lot like money. Now, whether you agree with that determination that less scarcity and lower value per token is better, that's really up to you, but that's how Digibyte has implemented it. Similarly to Bitcoin, Digibyte is mined over time, and it is only created and the supply is only increased through the process of mining. So as the network continues to be used and continues to be successful, more coins are mined. And speaking of that mining process, Digibyte, when it first released, was capable of reaching a block every 60 seconds and reaching transaction throughput levels of about 140 transactions per second. 1 minute is an already relatively low block time, but Digibyte has done a lot to continue to make this process faster. And one of the main ways they do this is over time, they have the block time, the target block time, every 2 years. And that means right now we are in at 15 seconds per block. And really what that means to the bottom line is that more blocks generally means higher transaction throughput. But obviously there's security concerns and other things that come along with that. So it's not as simple as just making block time super fast, because verification, validation, all that stuff has to happen in that UTXO model for those blocks to be mined successfully and securely. All that said, by 2035, Digibyte is expected to reach its full supply, and the Digibyte chain is looking to reach a transaction throughput level of 280,000 transactions per second, which is astronomical if you think about what speeds we're getting today. At the same time, I think though that 2035 is a long way away, and I definitely am not going to sit here and tell you that I don't think by 2035 we are not going to have solved the problem of decentralized distributed consensus at scale. I think it's possible. Whether Digibyte solves it or someone else or multiple people, it's going to happen. At its genesis in 2014, Digibyte was largely the same as Bitcoin. There were a few tweaks, a few things that were separate. First of all, the supply and the halving of block time and some of those core rules and principles that are in Bitcoin that we hold in crypto near and dear to our hearts. Digibyte, though, over the course of 2014 and 2015, underwent a series of hard forks to really drive home that vision of being a UTXO-based blockchain capable of handling the scale and the demand of global e-commerce. And subsequently, through those hard forks, Digibyte became less and less like Bitcoin and more truly its own platform altogether. So let's break those down, talk about what those hard forks included, and that will really bring us to what Digibyte is all about today. Now, as we know, one of the big threats that's often touted in Bitcoin is the centralization introduced by these large mining pools and the large entities like Bitmain behind them. Whether this is an overblown concern or not, Digibyte thought that in a proof of work environment where hash rate really rules the roost, they needed a way to protect from those centralizing forces. And the first fork that Digibyte went through in 2014 was called Digi Shield. And Digi Shield was there to address that problem of the centralization of the proof of work process. So let's talk a little bit more about the problem. First of all, mining is a very profit-driven business. And when mining rewards are high and the difficulty, the relative difficulty of the proof of work puzzle is low, these mining pools, these large entities like Bitmain, they run rampant and make a lot of money because they have such a large amount of the network hash rate that they can win out in that proof of work race a lot of the time. And in this ecosystem where there are multiple proof of work chains or multiple blockchains to be mining on, large scale miners were really able to jump from blockchain to blockchain with large amounts of hash rate at their disposal to follow the profits. And what happens is that for blockchains like Bitcoin that react relatively slowly to the adjustment of hash rate, this creates a perfect storm for large entities to come in and take advantage of relatively low difficulty of the mining process and reap massive rewards. And as a result, sometimes what can happen is that when large proportions of hash rate leave the network in mass, the adjustment of the difficulty level of the proof of work puzzle does not drop right away. There's latency, it takes time. And so the blockchain itself can freeze altogether because there's not enough hash rate there to reach consensus quickly enough. And this has happened in the past to a lot of different blockchains, and it's something that Digibyte wanted to solve. In Bitcoin, the mining difficulty algorithm adjusts the mining difficulty every 2016 blocks. meaning it does take some time for that overall process to adjust. And that means that it takes a lot of time in some cases for that mining difficulty to adjust when there's a large fluctuation in overall hash rate. Luckily, Bitcoin has a lot of really steadfast miners, and a lot of these large pools don't really leave and stop mining Bitcoin because it's really profitable for them. So it's not as much a problem for Bitcoin, but especially for these other proof of work chains that had relatively low volume and less hash rate, they needed a solution. So Digibyte is basically taking a more aggressive adjustment pattern or methodology for their overall mining reward adjustment. And when I say aggressive, I mean aggressive. So Digi Shield introduced a mining difficulty retargeting system that changed and adjusted to network hash rate every single time a block is mined. So back when Digibyte was first starting out, that was every 60 seconds. Now, difficulty retargeting of the mining algorithm and the overall difficulty of the proof of work puzzle or challenge is now down to 15 seconds, meaning there is little to no latency for the adjustment of the proof of work difficulty level overall from block to block. And that means that Digibyte overall was less susceptible to the large exodus of hash rate or the introduction of a ton more hash rate. And what this does is it prevents the insane fluctuations that happen naturally in a proof of work blockchain from sending the network into a spiral where blocks are being mined far too quickly because the hash rate is a lot higher than the overall difficulty in relative terms. And conversely, it prevents the network from stalling altogether when the difficulty is too high and the overall hash rate is too low. Now, this is a balance that all proof of work chains and some other ones really have to contend with. And after Digibyte introduced this idea of difficulty retargeting at every block, other blockchains like Dogecoin and Zcash have also implemented this same technology. So that is definitely proof in the pudding that this was a pretty cool idea and it worked out. Then in September 2014, Digibyte underwent another fork to introduce something called multi-algo, which was a hard fork that really introduced 5 unique proof of work algorithms to the network for consensus. And yes, you're hearing me right. That means there were 5 unique consensus processes all running in parallel on this Digibyte blockchain. Now, in this new mining process, that meant that one proof of work algorithm was able to reach a block every 1.5 minutes. And that means that today in the Digibyte blockchain, each one of those 5 unique proof of work algorithms reaches consensus on the latest block every 1.5 minutes. That's 15 seconds times 5 unique algorithms, meaning a 1.5 minute round robin format. And these algorithms, or this update to multi-algo, introduced 5 different proof of work algorithms that some of you may have heard of: SHA-256, Script, Skyne, Grossel, and Qubit. So you may be wondering why they did this and what the point is. Well, first and foremost, a lot of the interest in moving to multi-algo was to further decentralize the process, meaning specialized miners for a specific platform or algorithm could not dominate the entire network. They'd only be able to dominate one part of it. And beyond that, it diversified the overall consensus process as a whole. So obviously this means that if a big entity like a Bitmain wanted to dominate the entire Digibyte network, they would have to specialize hardware to run on 5 different algorithms, all contributing to consensus on those algorithms, and they'd have to take over each piece individually to really overwhelm the network. And something that's also touted with this is that it makes Digibyte more 51% attack resistant. That's sort of a toss-up, yes and no. It does mean that if an entity were to 51% attack or have 51% or more of the total hash power for one algorithm or one proof of work algorithm, they would only be able to take up that one piece. They would only be able to dominate that one consensus process. However, it doesn't really stop an entity that has a 51% majority of hash rate or more over the entirety of the network, because it's all relative to the hash rate overall. So to be honest with you, the 51% attack resistance, it's there, but it's not as stated and as perfect as some people may think. That said, the complexity of a 51% attack in Digibyte is a lot higher, and that makes it more difficult for someone to pull that off when it would have to be very specialized, very targeted, and there would have to be a massive hash power output that I don't know is necessarily feasible or affordable overall. I don't know if it makes economic sense to do it. Now, the other side of this is that it makes mining more accessible because some of these different algorithms are maybe more often used than others, and ones that are less used would be easier for people to get into if they don't have the type of money or resources to contribute an insane amount of hash rate. They might still have a chance of winning that proof of work puzzle and, as a miner, earning some rewards. And by that hand, I think that overall, by diversifying the consensus process and implementing this relatively complex update, Digibyte was very successful in this hard fork. But one thing as a software developer that I can't get over in a way is that by implementing this, they broke Digi Shield, because now there are 5 algorithms and Digi Shield was only built for the original proof of work algorithm they were using. So when you break something, you introduce a breaking change, that's usually not something you want to do. But that being said, they pushed a fix really quickly after that, so I'll let it go. That being said, a couple of months later, they released a new hard fork again that was there to introduce multi-shield. And just like the name entails, that was bringing Digi Shield technology, or the mining difficulty retargeting, to all of the 5 unique algorithms introduced by the multi-algo hard fork. Again, my opinion is they probably should have waited until December 2014, released multi-algo and multi-shield at the same time, and not done this hard fork that broke something that then they fixed later on. But again, that's me nitpicking. It's not a big deal. In the future, obviously, I doubt they'll do it again. Now, moving on to the next hard fork. In 2015, a hard fork called Digi Speed was introduced. And as you probably guessed from the name, it was all about speeding up the network and improving the overall transaction throughput and the speed at which confirmations were reached. Now, Digi Speed officially moved the block time target down by half ahead of schedule. So even after just 1 year rather than 2, that block time, or target block time, was cut in half early. Digi Speed also increased the overall block size by 10-fold. Now, this went from 1 megabyte size blocks to 10 megabyte size blocks. So that means around 10 times more transactions can fit into that block at a time, meaning if you have blocks being mined every 30 seconds or every 15 seconds, and you have 10 times the number of transactions in each of those blocks, you're getting more transaction throughput. And obviously one of the concerns is, how much can someone fit in a block and actually validate? And can they validate all those transactions, meaning the miners, in that short amount of time? So that's always the concern in proof of work. The answer was yes, Digibyte did not have problems with block verification and that sort of thing, so that's a good sign. One of the things that I tried really hard to find details on, but I couldn't, was the improvement of transaction propagation on the network, so making that algorithm more efficient. Apparently, this was based on Microsoft research, and Digibyte used this and implemented this in the Digi Speed hard fork to make the overall transaction and block propagation process more efficient and fast. But I couldn't find any real details about this, and it's very closed source, it seems. So that's a bummer, but I'll take their word for it. And this massive block size, plus the overall speed at which blocks are mined, like seconds, we got to 15-second block times very fast, means that Digibyte to this day is the longest blockchain in terms of block height, meaning the most blocks have been mined in Digibyte of any other blockchain out there. So the claims that they have about the speed and the overall usability of the network from a scaling perspective, it's there. They're walking the walk and not just talking the talk. Again, it's just block height. You can take that for what you will. You have to think about how many people are actually using the Digibyte network. There could be more. They don't have enough adoption. They don't have enough hash rate. They don't have enough people using it yet. But it is proof that this technology can work, and that it is working the way they intended it to. And then finally, the last hard fork we're going to talk about today is the one that introduced segregated witness, or segwit. For those of you who've been following Bitcoin for a long time, segwit was a huge topic of conversation to improve the overall scalability of the Bitcoin network, and it ended up taking effect. And I believe Digibyte was one of the first networks to really implement this and prove the concept out in a proof of work environment. So bully for them for doing that, that's awesome. Basically what segregated witness does is it takes the confirmation and witness information, that data, out of transactions, and that makes the transactions subsequently smaller in size, meaning that more transactions can fit in the same size block, And so now you have 10 megabyte blocks with smaller transactions, and they're mined every 15 seconds. That means you're getting a lot of scale, you're getting a lot of speed, and you're getting a lot of transactions in each block. So again, you kind of see these pieces fitting together. You want to decentralize with multi-algo, and you want to make sure that Digi Shield is there to retarget that block time to prevent centralized parties from dominating and freezing the network. And beyond that, now you want to further increase the speed, and doing that in a handful of ways: increasing block size, reducing block time, and overall reducing the transaction size is another way that you can get more transactions into each block. So all of these things make sense, and I really applaud Digibyte for being creative with their platform and not letting the Bitcoin maximalists saying you can't create a proof of work chain that does anything else, it's garbage. Litecoin faces the same thing. I really like these projects. I like Litecoin and I like Digibyte, and I love Bitcoin. Bitcoin's always going to be something super special to me and an example of what cryptocurrency should be. That's 10 years of success right there. If we can get there for other projects, I'm happy. But yeah, there's so many forks in a very short amount of time that introduced a lot of new features and eventually made Digibyte the largest blockchain by block height. Take that for what you will. I know we talked about it just a second ago. But now let's briefly discuss the layers that make up the Digibyte ecosystem, because there are a handful of things that you need to know there. So at the very base layers, there is the core protocol layer. This serves as the foundation for all the other layers of the overall infrastructure, as you'd expect, but it establishes that baseline layer for communication and overall data exchange between nodes and entities on the network. And then sitting right on top of that base layer, you have the public ledger and the digital asset layer. Obviously, this is where that main blockchain protocol sits, and this is where all information and value is exchanged. This is where those security features are built in to make it difficult for someone to manipulate data after it's been created. And it also provides the incentive and disincentive for miners and full nodes in the network to do the right thing and also not do the wrong thing. And at the very top, you have the application layer, where a lot of the APIs and the different front-end facing pieces of the Digibyte protocol exist. So that includes APIs, front-end user interfaces, different protocols, interfaces, and then obviously applications that Digibyte has built on top of their blockchain protocol, like Digi Id. Now that we've talked about Digibyte's past, we talked about where we are today, where is Digibyte going in the future? Well, they're focusing on a couple of things right now. Adoption is number one, and I think a lot of other platforms are doing that. They're heads down trying to build to get people to use their platform and prove their concepts out. And two, making the network more secure overall and less prone to centralization. In my opinion, as someone who's admired Digibyte for a while, I think they really struggle to get actual adoption. I think personally that Digibyte has a strong offering. I've used Digibyte products and it is fast, it's well built. There haven't been any problems that I've experienced myself using Digibyte to send value or send transactions and playing with their digital identity solution. We'll talk about that in a second. But Digibyte's goal is to get a wider array of different people to use Digibyte for things, actual things that will introduce transaction volume, get people locked in, and also maybe encourage developers to build cool stuff using Digibyte's network as the data exchange layer or the digital ledger layer. So how are they doing that? Digibyte is first going after the education side of things. Jared Tate is very active on Twitter. He gets a lot of attention. But beyond that, they're really putting the marketing feelers out there to talk about Digibyte, what it's capable of, why it's great, and making it very clear for people. If you go to their website, it's a lot of marketing. There's a lot of cool graphics and stuff on there, which sometimes can be annoying, but it does a really great job of communicating what Digibyte's all about and why someone should care about it. And second of all, Digibyte is targeting different industries that really rely on scale and overall security of a blockchain network, and that would be IoT and AI. Obviously in IoT and AI, there's a lot of data being moved, there's a lot of value to that data, and obviously you need a secure layer to move that data around to exchange value. And so Digibyte is targeting those industries as a place to apply the Digibyte ledger. Now, beyond adoption, Digibyte is placing some serious focus on making its proof of work algorithms resistant to ASIC mining, which is really becoming the boon of a lot of proof of work networks out there today. and others because they're so specialized, and ASICs are dominating the mining process these days. So if you're not familiar with what ASICs are, they're a specialized piece of hardware that is tailor-made to run the processes required in iterative hashing to solve a proof of work puzzle or reach consensus in a proof of work environment. And because ASICs are so specially made to create amazing hash rates and to do their one job super well, they've largely hurt GPU and CPU mining. Like now CPU mining is a thing of the past. People can't mine with CPU. GPU survives, but ASICs are what dominate. And obviously when you have something that dominates so heavily, it's a threat because a centralized party that has a bunch of resources to dump into ASICs can really take over a proof of work network in theory, and that's obviously scary. So Digibyte's putting a lot of research and time into evaluating how their 5 proof of work networks can be resistant to ASIC mining. And one of the ideas that Jared Tate, again, the creator of Digibyte, has thrown around is targeting the exact reason why ASICs are so special: their specialization for hashing and their specialization towards a specific algorithm. Jared Tate thinks that if you create an algorithm that morphs over time, that changes over time, specialized hardware could never keep up with all of the transmutations and different crazy changes to a consensus mechanism that would occur over time. While people that have more flexible, less specialized hardware could still do well and adapt to all of those different changes in consensus. So the idea that Jared was bringing up is having a consensus algorithm or mechanism that changes about every 10 days. And one of the ways that you could mine, or the ideal way that you could become a miner in that morphing consensus mechanism, is using an FPGA, which is a field programmable gate array. And an FPGA is essentially a computer processor that can be reprogrammed at the chip level, so at the core architecture level, on the fly, over time, pretty much as many times as you want. So it can adapt to new processes, new algorithms like Jared Tate is bringing to the table. And FPGAs are already used by NVIDIA and by other graphics card and processor companies for different purposes like AI and machine learning. And obviously that presents the opportunity for blockchain to utilize this technology to resist ASICs. All in all, it means that the idea or the theory here is that if you have a consensus algorithm that mutates over time on a cadence, no hardware or software could be optimized enough to dominate the process like ASICs are today. And that's the key. You have a moving target, so even if you have 10 days and you spend that 10 days getting really, really optimized for that specific algorithm, that specific process, it then switches on you and you have to reprogram and recalculate. It levels the playing field a little bit. Now this is all well and good. This is really cool, and I myself spent a lot of time reading and geeking out over this because I think this idea is fantastic. However, the difficulty is when and how is this going to be implemented? A mutating consensus algorithm is very difficult. There are a lot of things about that that make it hard to implement. And the first one of those is, how do you get everyone in consensus originally on what the algorithm is going to be? Because we know that hard forks are not always easy because not everyone knows about them and gets up to date on the latest consensus algorithm. So how are we going to keep miners honest and continue to keep them incentivized to reprogram those FPGAs over time? That's an important one. And how are they going to build this? So obviously not a question I have the answer to, but I'm very excited to see what the future holds. And of course, it wouldn't be a Token Talk Tuesday, or Thursday in this case, without talking about some developer stuff and where Digibyte is in terms of developer support and what they have out there for developers to use. So right now, there is no smart contract platform on Digibyte, and subsequently there's no SDK or any of that stuff to implement smart contracts because there aren't any. However, there are APIs that have been built out to interact with the Digibyte blockchain in different applications. So I did hear about applications in the gaming world where microtransactions can be facilitated using DGB tokens over the Digibyte blockchain because it is fast enough to do in-game transactions. That's a really cool idea, and I've seen some development work done on that. I don't know how successful it was, but definitely a cool idea. Now, one thing I did get to use that I was very impressed with, and I talked about this a little bit before, that's Digi Id. It's a digital identity platform that allows you to use your Digibyte keys as a single sign-on for different applications. And it prevents you from having to use a username and password as your credential because your keys are your username and password. So when I use this, I use it as just a basic authentication for an app. Never really saw the light of day, but it was just an experiment that I did. And the documentation was really easy. They had JavaScript documentation, which is what I use a lot. And it was really easy to implement. No complaints, no questions asked. So I really like to see that. All in all, it was really easy to get the Digi Id mobile app connected up to the web app that I was building, and everything worked like a charm to have single sign-on using a Digibyte key pair. Now, again, not a lot to report on the development side, but as more developments come, pun intended, I will let you guys know. Overall, what are my thoughts on Digibyte? To be honest with you, I'm surprised that over time there hasn't been more noise and more hype around Digibyte. I know that the price went super high and everyone's like Moon Lambo. I don't really care about that. I mean, using Digibyte for what it's really good at, fast transactions of value. I'm surprised that we haven't seen an e-commerce provider take that plunge and use Digibyte mainstream for their platform. And I'm surprised that more people aren't talking about it, because they really have implemented some really cool stuff and done something relatively cutting edge. And that impresses me. Now, obviously there's a long way to go. You know, introducing smart contracts to the mix would be great. Introducing ASIC resistant mining is really crucial in my opinion. And further improving the overall speed and transaction throughput of the network to get to that level where they could theoretically compete with Visa, because that's what everyone talks about. Crypto will get adoption when we get to the point where we can compete with Visa in transaction throughput, so people will actually use it. To a certain extent, I don't know if that's the only way that crypto gets adopted. However, it will definitely help, and Digibyte's main goal is to get there and blow Visa out of the water. So I cheer them on, I'm rooting for them. I really like what they have so far. And I'm really curious what you have to say, what you think about Digibyte, because at the end of the day, that's why I make these videos. I want to know what you think after I tell you what I think and what I know about the platform, and I always learn cool stuff from you, so thank you in advance for that. The bear market's hurt a lot of projects, and I think Digibyte is definitely one of those. Not a lot of people are talking about crypto, and when they are, they're talking about the big names, and a lot of it is just negativity, and that sucks. But all these projects are keeping their heads down, they're building, they're making something real, and when things start to turn around, it will be because of those projects that ignored the negativity, ignored the prices, and just kept building. That's the way to do it. So Digibyte has my support, they have my best wishes, and I hope they're super successful in the balance of 2019 and beyond. Oh, and by the way, don't forget to check out more of my Token Talk Tuesday videos. I will have them linked in a playlist here on the screen for you to click. I really appreciate you guys being here, truly, and spending the time on my content. Thanks so much. Cheers.